afternoon, good morning. As I mentioned, I'm Khairallah from AWS, so I'll be going through Lakehouse, but more importantly, I think the idea of reinventing your business with data and how the Lakehouse concept can be core to that. And we'll go through some slides, then we'll have some time for Q&A. So hope this is a great session for everyone that was able to join today. So I think, to put the Lakehouse and just reinventing your business with data in context is really a couple of macro trends that we've seen and heard from customers over the past few years. And it's really just the central role that data plays, not just in decision making, but really in being innovative and being able to deliver better services to our customers. And you think about, what's really the business value of a modern data strategy centered on the Lakehouse. And AWS worked with IDC on some statistics around being able to generate more revenue, right? So it's not just about, getting more insights. Of course, that's still super important, but really, how do we take and monetize our data, right? What's the return on investment on making a change? And so particularly if I have on-premise systems, how do I think about, breaking down data silos and moving to a modern data strategy with the Lakehouse at the center? And there's some interesting statistics around 415% ROI and 48% reduction in cost of operations by leveraging managed databases. And so lots of information that's available on the business value of moving to a Lakehouse. But also like what does it mean to be a data-driven organization? And besides the Lakehouse term, which I'll spend some time defining, I think this is really where I spend a lot of time talking with customers about is how do we make data an organizational asset? How do we make it accessible? And in today's modern requirements is, yes, there's a core set of internal analysts that need to get access to the data. But importantly, we want to think about providing data to third parties, to partners, to suppliers. How do we think about not just internally generated data, but also third-party data, and thinking about ways that this can, change the way our data architecture is actually designed. But then, more importantly, how do you put the data to work, right? And there certainly is a lot of value in reporting and analytics, but really moving to more predictive and leveraging machine learning automation to help us make better decisions are all the core of what becoming a data-driven organization really means. Now, there's challenges, of course, right? I think all of us are aware of some or a few of these items. And so one is just the volume of data that's being generated from IoT devices, mobile devices, thinking about, particularly if I have the on-premise system, I might have a data warehouse and a data lake that are separate. How do I think about, these different silos of data that make decision-making difficult? And then, most customers I talk to have some kind of a strategy around machine learning, but really they don't necessarily have the deep mathematical skills or the resources or being able to pay for third parties consulting to help with that. And so, more we think about this democratization of machine learning and how do I make it more prevalent? And of course, depending upon the region, the industry, but really, security is job one, for everyone, right? Including privacy and complying with different state and federal and international regulations around data privacy are all, challenges that we hear along this journey to becoming a data-driven organization. Now, oops, sorry, I went the wrong way. Now, one thing that's actually accelerated this journey to the cloud and accelerated the Lakehouse architecture, including modern data strategies, has really been, the reality of the last 18 months that we all have lived through. And we've seen, decisions being accelerated, and it's the importance of data and migrations to the cloud have become accelerated because customers needed to make better decisions faster, like unprecedented market changes. How can we think about using data to make decisions with uncertainty, right? But beyond just surviving, what are the unique characteristics of companies that have really thrived, right? Putting their data infrastructure to work, right? Think about some examples I'm sure we use probably in our day-to-day lives around Netflix or gaming customers that are able to deliver massive online gaming, and just this whole way that information and delivery and really that customer experience has changed, whether it's through online pickup or remote work, and really putting data at the center to help not just survive but also thrive in the current environment. And to do that, and really the heart of a lakehouse strategy is centered around thinking about this concept of modern data strategy, where I'm able to leverage and think about the application first, and then leveraging a flexible set of purpose-built databases that are fully managed. And so moving to more database as a service, right? And not just having to make compromises on one database, but letting the application requirements actually drive the database technology that's used, whether it's relational, non-relational, log analytics, data warehousing, and really having this full spectrum that I can very quickly and easily adapt to be able to meet the needs of my business. And then also, mapping that back, to AWS services, across Amazon Aurora or DynamoDB and SageMaker and EMR and Redshift. And we'll go through a little bit of those details, how it relates back to the Lakehouse architecture. But knowing you have this full flexibility by looking at AWS and AWS native services to help drive your modern data strategy can really accelerate not just cost savings, flexibility, but really think about this idea of monetizing my data and being able to react faster to market conditions. For those of you who are fans of YouTube videos, there's a lot of great information from previous AWS reInvent, which is our annual customer conference, that are up on YouTube, on sessions of not just how customers have leveraged, AWS customers have leveraged the modern data strategy, but as well as Amazon retail business and its transformation from a monolithic database architecture to a modern data strategy. And if you're curious about the bigger picture here, I'd encourage just looking up some of those sessions from previous reInvent talks on how companies, including Amazon.com, have leveraged a modern data strategy to survive and to thrive. But when it kind of breaks down, I think kind of like going maybe a little one step deeper, we think about this road to the modern data strategy as really having three different pillars. And they're not sequential in terms of you have to start with one and then progress through the others. Depending upon the application and the needs of the business, you can actually start at any place. But really, I think when we kind of work with customers to think, what's my data strategy? We need to modernize, to unify, and then to innovate. And I'll tie back how that is to the Lakehouse in subsequent slides. But first, I want to think about, again, this isn't necessarily a linear progression, but oftentimes modernization as the journey to a modern data strategy. And to modernize, you want to be able to leverage, the best of a scalable infrastructure, security, of course, being job one, but really moving from, commercial perpetual license type deals and really the old guard database infrastructure to a modern infrastructure. And I'll just give one quick example and we'll get into some details, but I think a great, short case study is around Samsung and how they moved from old guard database on premise to Amazon Aurora, right? And so some of the statistics here, being able to migrate 1.1 billion Samsung accounts to Aurora with really minimal to no service disruption, right? But then also, thinking about this critical workload that is at the heart of Samsung's business in terms of delivering features to their customers, but being able to do this migration of these complex workload in about 18 months, right? But being able to look at not compromising on performance and being able to reduce costs are really at the core of the Samsung case study. And there's more details available on AWS's website if you're curious, but just kind of give you a sense of this modernization and moving from, monolithic legacy, systems into a modern data architecture with Amazon Aurora at the core. But moving this legacy infrastructure requires a lot of and why do customers actually invest in this movement is because these on-premise database systems oftentimes come with a lot of heavy lifting, right? Now, my personal history, I spent a number of years across on different providers like Oracle, And look, you know, in 1990s, 2000s, you know, this was, you know, standard practice. You know, hardware had to be delivered. We had to do performance, you know, scaling, capacity planning. You had to purchase, you know, servers and racks, and then compliance, and then, you know, perpetual license deals and audit licenses. And I mean, this was just, you know, pretty much, you know, the standard, right? And today, you know, there's a different world, right, where I can just pay as you go. I can remove some of that undifferentiated lifting and think about this world of managed or database as a service, right? And when we think about database as a service, one of the important lessons we've learned is that there's rarely one database that can meet the needs of every application across the enterprise. Now, certainly, you know, not to say you have to use every database in every application. You know, we're working with our customers and partners and AWS solution architects to really come back with a recommendation, but knowing you have this flexibility, right, across relational, key value, document, in-memory, right, ledger and time series databases, where instead of saying, okay, we've invested this hardware on premise, therefore, how does the application leverage what we have? You know, turning that around to say, what does the application needs? And of course, you know, understanding how AWS is managing backups and patching are super critical, but those become more like plugging in an outlet, right? So the electricity is there. How is ability, right? And so thinking about, you know, not to push the analogy too much, but AWS provides the electricity, in this case, it's the database, and not just a single database. And I referred back to the story of Amazon retail that was core to this, where today, you know, whether it's moving from Prime Day to holiday season to, you know, shipping, logistics, the core to this strategy is really built around purpose-built databases. In the previous slide, calling out Samsung is really being able to leverage, you know, the right database for the right application, and really thinking about, you know, this application developers and choosing the right data store becomes core to this idea of innovation. Now, that kind of just set the stage as we kind of jump into more conversation around Lakehouse, but I think this modernization often becomes an important topic because, you know, we need the source systems that generate data, and oftentimes that's really where, you know, the application, and an application, I mean, it could be my mobile app, it could be my ledger, it could be, you know, the core, the heart of my organization oftentimes comes down to the database, and thinking about what that modern data strategy and that modernization piece becomes a critical piece. But then also we think about, okay, how do we get value from that data, right? What really, you know, breaks down that data silo? And the session is you know, primarily focused around this concept we call Lakehouse. And by Lakehouse, we just really mean is this breaking down of data silos, where perhaps previously I would have a data warehouse and then separately a data lake. And at its core, Lakehouse says is that I have a unified set of data that, depending upon the workload of the analyst, whether it's a data warehouse, a data scientist, a program like Spark or Scala, or Python using Spark, should all be able to access that single data store. And that's really at the heart of unification of data. And so just a quick customer example from Equinox Fitness, right? They moved from an on-premise a data warehouse to this Lakehouse architecture that combined Amazon Redshift and Amazon EMR. And you can see here, you know, there's some things around cost savings, right? But, you know, particularly if you're moving from perpetual license or on-premise licensing deals, in many cases, you know, what you pay annually to AWS is a small fraction of what your annual maintenance was, let alone the initial license procurement up front or the hardware costs. But then more importantly, being able to rapidly adjust to changing market conditions where, you know, you can move or daily, you can within the minutes or within the seconds or real time from mobile devices, right? And, you know, one quick example, again, more details on AWS's webpage if you're curious about Equinox and some of the cost savings and benefits they saw, and examples across other organizations as well. But really, I think at the core of this, and coming back to our topic around Lakehouse, comes, you know, and really this center place that the data warehouse plays in the Lakehouse. And there's lots of ways to deploy modern data strategy. This isn't the one the one answer from AWS. We'd love to work with each of our customers and partners on really designing the right architecture for your specific needs. But some pattern along this becomes where most customers start. And so again, just to kind of define Lakehouse clearly, the premise of it is that most analysts in the organization probably speak the SQL language. And so we talk about and Scala, and all of that can be accomplished. Tools like visualization from Amazon QuickSight or Tableau or MicroStrategy, applications that know the SQL, and just this whole developer community really comes back this idea of a highly performant, highly available data warehouse at the core, but also knowing that what we said earlier around new data sources from IoT devices, streaming sources that are coming in from Kafka or Kinesis, log data, application data, but also this idea of third-party data and how I can monetize and leverage third-party data. So from AWS as one of our data sources, we have a service called AWS Data Exchange that has a large number of third-party data sources that you can leverage. And so moving beyond just internally generated data to third-party and market data, or even monetizing your data sets and providing that to your partners, excuse me, can become an important concept as well. But besides that, kind of idea of different data sources, another core piece of the Lakehouse then becomes, and not forcing loading all of your data into the data warehouse, whether it's Redshift or a different cloud data warehouse, but there's an important feature of Amazon Redshift called Spectrum that allows you to really combine the best of a data lake with the best of a data warehouse. And so you don't have to import the data into Redshift to get value from it, particularly for patterns that have data coming in as a stream, or leveraging if I have a machine learning team that is using data that is in the data lake. And so Redshift has a construct called external table that you can point directly to data on S3 without having to load the data. And as data changes, as it gets updated into S3, you can immediately query it. And this kind of comes back to this Lakehouse architecture. So I mentioned this merging of the data warehouse and data lake at its core, and features like Spectrum and like federated query really allow that to be a simple from the end user. So if you're a business intelligence user, data analyst, you simply see a collection of schemas and tables and typical database objects, right? That are all secured through access control. You can limit to third parties or to internal resources, but whether the data is local to Redshift, whether it's files on S3, whether the data resides in a completely separate database like Amazon Aurora, giving this simplicity to the data analyst to just seeing the common database constructs, but then not having to compromise on performance, I think are the core to the Lakehouse, and really Amazon Redshift being at the center of that Lakehouse architecture. Now, Amazon has been investing significantly in Amazon Redshift and certain features that really help enable this Lakehouse architecture. I'm not going to go through each one line by line, but just knowing that the pace of innovation continues, and we're excited, in the coming months to share even more how we've evolved Amazon Redshift, just given how the criticality of the data warehouse workloads to Lakehouse approach, and knowing that the full investment of AWS behind Redshift as the core cloud data warehouse to help our customers. But a couple of things I did mention to Lakehouse I wanted to call out that really help rethink the way the data warehouse is deployed, and really helps accentuate this concept of breaking down data silos with Lakehouse. And the first is a feature of Redshift that we launched called data sharing. And so, just kind of going back to my analogy from my previous employer, Oracle, it was great, great database, one of the best databases in the world. I loved my time at Oracle personally, but there was a different perspective, right? Where you had these monolithic systems like Oracle Exadata, and it was about managing and managing resources on that single cluster, and workload management, performance tuning, which were all super critical to deliver. But today, thinking about like a layer in Redshift that we call Redshift managed storage. And so this is really the persistent state of the database, right? But now instead of having a single Redshift database or cluster connecting to that Redshift managed storage, you can have multiple independently sized data shares that are compute resources that connect to that storage. And so with Redshift, you have the separation of compute and storage, but then the flexibility to say, well, the pattern at the left says I might have a batch process that runs 24/7. And so I'm going to have a certain sized, quote unquote, data warehouse to just do that ingestion of the data. But then I have different business groups that need a consistent view of that data, right? But they need to have that segregated out into their own compute pool for SLAs, right? And so you could have, here we have 3 examples called a data science cluster, dashboarding cluster, ad hoc query cluster. And this idea of separating out into their own compute pools, but not saying it's any sort of like eventual consistency here. This is a fully consistent data model that's at the heart of Redshift being an database, right? So the table is updated immediately. Any of the compute pools that are accessing that will see that same view in a completely read consistent manner. And so this first pattern at the left, where I have different consumers of that data, they can be in the same AWS account, different accounts, eventually even across spanning different AWS regions, whether it's internal, third parties. If I need to share data, I can simply share an endpoint and have external parties securely start sharing that data. But the other piece of data sharing we see a lot is kind of the second idea on the left, on the right, where there's no central sort of ingestion piece, right? It's really about, each of the different business units or partners, whether it's finance, research and development, marketing, just a few examples, right? They all have and subscribe to a common set of tables that are fully consistent, but they might have their own data they need to ingest in there as well, where there really is no central place to singularly do updates. And so this idea of data sharing, really kind of helps accentuate this concept of Lakehouse, because now I can deconstruct what otherwise would have been a monolithic deployment from a data warehouse perspective into the individual business units and think about what their SLA and what their compute resources are without having to do performance tuning or resource sharing, because they each have their own share that they can then operate on. Also behind that, and I think core to this idea of Lakehouse, is really this democratization of machine learning, right? So I talked earlier why we put Amazon Redshift at the core of the Lakehouse architecture. It's because it's ubiquity of SQL language, right? And certainly there are lots of tools to be able to build, test, deploy ML models in a wide variety of programming languages. But for the Lakehouse user, for the data warehouse user, just being able to simply select a data set in Redshift, provide that as the training set, right? And then automatically behind the scenes have a function called Sagemaker Autopilot, determine the right ML model, and then deploy that model back into Redshift, leverage it through a SQL statement. And means, we provide that insight into SageMaker Autopilot, but that's really transparent to the user of the database, right? They simply are using SQL to issue commands like create model, and then once that model is created, being able to select it. And whether you have SageMaker Autopilot select the model for you, or whether for more advanced users, you want to specify the exact ML model, the process works the same. And so data stays within Amazon Redshift. You get to be able to leverage the full capability of the Lakehouse architecture, but really the simplicity of just the SQL language to be able to leverage machine learning, where you don't have to be the PhD in math to get the value from this data. And the other area that comes back that we've invested from a Redshift perspective as it relates to Lakehouse is native support for semi-structured data. So there's lots of different approaches to be able to solve this problem, to be able to think about a JSON file, right, that is nested. And what's unique here is that the file itself defines the schema. So in previous versions of Redshift and other databases, if I had a JSON file, I would have to specifically map each attribute to a table in Redshift, right? Whereas today, like with our super data type, you simply have, in this example, you load it into Redshift, copy command or ETL processing tool, and the file itself defines the schema, right? So I'm not predefining the schema. And if I need to query it, using the dot notation of SQL, so not just querying the document itself, but querying the individual nodes in that document. And so this can greatly simplify the end user experience because they simply have a JSON file. It's loaded into Redshift in a single command. The document itself defines the schema, and now you can start doing standard SQL operations against that to really simplify the data pipeline, but more importantly, unlock this value of what otherwise was non-traditional data source from a data warehouse perspective. That is really this idea of breaking down data silos as the heart of Lakehouse is a great feature that customers have been excited about to leverage within Redshift. But there's also kind of a different way that Lakehouse plays in terms of unification of data. And I talked a lot about the BI users, the data analysts, to be able to leverage this power and not having to make trade-offs between data that's local to the database or data that's external that features like Spectrum and Redshift can deliver. But there's also a large set of applications that need to be written that actually leverage where the end user of data from the Lakehouse is not a Tableau report or QuickSight report, although that is obviously still a large use case, but really, leveraging data within the Lakehouse or the core data. And the application itself needs to be written in languages like Java and Python or C and this full spectrum of different programmatic ways. And so Redshift has a full data API where the connection does not happen through ODBC or JDBC, but it's through the API itself. And so, we've actually seen, thousands of customers leverage the API that are making, tens and hundreds of thousands of API calls to be able to really, think about these data-driven applications and not just the data-driven reports. And the full functionality of Redshift from machine learning and data sharing applied to the API, whether I'm a data scientist using a notebook or a SQL command prompt, or that application that's serving up data can become really powerful in terms of breaking down the data silos that is at the core of the Lakehouse value proposition. But knowing that, I mentioned a little bit about, and probably a few slides on the house part of Lakehouse, right? But there's still that data lake piece, right? And so at the core of the data lake becomes the value of Amazon S3, right? And thinking about data frameworks outside of just SQL to be able to access that data. And so if I have these big data formats like Apache Parquet, if I have data engineering processes where I have data pipelines that I'm building, of which some of that data might get loaded into the data warehouse, some of it might remain separate. And really thinking about the power of Amazon EMR and being able to have flexible deployment mechanisms to be able to think about how this data is used. And so within Amazon EMR, we have invested a lot in the most performant and cost-effective execution engines for Apache Spark. You can deploy it on EC2 instances within Kubernetes, right? Containers as part of Amazon EKS. And really leveraging some of the foundational elements of the spot market on AWS to really drive cost savings and really thinking about this data engineering pipeline side of the Lakehouse and putting Amazon EMR at the center of that becomes an important way to think about driving efficiency and really breaking down those silos as well. So I talked a little bit about the modernization, the unification, and now just the last couple of slides to think about innovation, right? And more innovation is driven by machine learning. And it's been a core investment of AWS to really make machine learning available to a larger set of users to really see the value and power of ML. So here's a great example. I'm a big pizza fan myself, love Domino's. And they started off with this challenge of reducing their pickup and delivery times for online orders, right? And so remember earlier in the talk, I mentioned how the current pandemic has changed the way business operates. And a great example of being able to quickly adapt is Domino's to this new environment, right? So as online ordering increased, they wanted to reduce pickup and delivery times. And they really looked at Amazon SageMaker as really the core enabler to develop these forecasting models, and able to then, their stores to be able to, meet their business goal of delivery time in 10 minutes or less by really thinking about, and quickly being able to assemble data as part of the Lakehouse and leveraging SageMaker to be able to build, test, and maintain those models. And more details on customers that have leveraged machine learning that we can share. But at the core of machine learning and really this innovation is really the flexibility that AWS can provide wherever part of the spectrum of ML you come in. And so at its core, for builders, for developers, we have the machine learning frameworks and infrastructure, the ability to run MXNet, TensorFlow with the latest GPU processing units, right? With purpose-built hardware that can really accelerate the builder, the developer, the data scientist to be able to leverage the power of machine learning. But more and more we see customers such as Domino's earlier that are leveraging an integrated development environment known as Sagemaker and Sagemaker Studio. And it really can leverage the full spectrum of machine learning from data preparation, a feature store, a visualization in notebooks, picking algorithms, training and deploying and monitoring those. And so the power of Sagemaker at its core to leverage data within the Lakehouse, it really helps drive the innovation for many customers. But then thinking about beyond just that component in the AI services. And so if we kind of thinking about, I just have an application, I want to be able to leverage a chatbot, right? And so being able to use things like Lex and Poly to be able to do text to speech or speech to text to comprehend and translate and textract. And really just thinking about the application that's needed to then empowered by the AI services that really helps and democratizes this access to ML across a full spectrum of data. So that's kind of the end of I know we still have a few minutes left. I'm happy to take some questions, but really, at the heart of the Lakehouse is breaking down data silos. At the heart of breaking down data silos is this concept of a modern data strategy. And depending upon where you are on the journey to the cloud, thinking about modernization, unification, or innovation become core pillars to really getting more value from your data and being able to rapidly adapt to modern data needs, but also make innovation the core of how we deliver that.